All right, I actually think unintentionally I timed that right. So it's 6:40. It's kind of perfect, right? Okay, people are gonna trickle in here. So just so you all know, I'm also recording this. So just so you're aware, if you want to go back and check stuff afterwards, I'm going to post this afterwards. But I'm really glad to see all of you here. This is super exciting to have everyone in person. So it's just really great to see. Okay. The reason that I played the Blue Danube Waltz was if any of you have watched Squid Game, that's the music they walk into before all the scary challenges. And today we're going to be learning about bash scripting, which is only slightly more fun than that. So today, hopefully we can give you a sense of a really essential tool to any software engineer, to any programmer, and just help decode some of the mess that you're going to see in the bash scripts, okay, on a day-to-day basis. So before we get started, some quick logistical announcements. We still have some enrollment codes. So if you are not officially enrolled in the course, not to worry, come talk to us afterwards. And I think there's also the link, right? Yeah. I'll put that at the end. There's a link to fill out the enrollment form if you haven't already. We're going to take anyone else who's still interested and distribute codes on a randomized basis, okay? But just so you know, if you're not enrolled, you have an opportunity to. If you use macOS, check Piazza, because for the next few assignments, we want to standardize things between Linux tools and macOS tools. So basically, there's a post on there just telling you a little bit of stuff to install. It's no more than like a 2-minute exercise, but should be important. Everyone, check Piazza. That's where all of our announcements and stuff are going to go. So just if you aren't, just sort of make a habit of it. Weekly, bi-weekly, doesn't need to be too often, but that's where we put our updates. Today's attendance is at this link. The code, the secret word is sliver, because we had sliver today. Okay. And again, this is the enrollment code. So are there any questions about logistics before we get started? No.
Yes. Two more things. One thing is, if you have any questions, go to Piazza. We have a live Piazza thread. Just ask your questions on there, and Aaron and I will answer them. And the second thing is, we can do introductions again, because I don't think you met any of us in person. So let's start with Aaron. We can go this way.
Hello, my name is Aaron. I'm a sophomore in computer science, and I'm taking this course because I'm really interested in the tools we're about, and really cool that we're able to do this.
And you'll be giving some lectures as well later on this semester. I'm Addison. I gave last week's lecture, and I'm studying CS and stats.
I'm Sean. I'm giving this week's lecture. I'm studying EECS, Applied Math and Cognitive Science. And I have the unlucky role of trying to follow up Addison's lecture. But again, if you have questions, please put them on Piazza and they'll handle it really quick. Okay, awesome. So great to meet all of you in person. Again, are there any questions before we get started, or let's just get to it? All right, let's get to it. Just a brief slide before we get to demos. This is a fun chart by XKCD on basically how much time you save when you automate tasks that you do often. So if you do the task maybe 50 times a day, maybe it's more worth it to automate it, right? And it depends on how much time you shave off too. If it's a really long task, like say sorting a whole file or sorting a whole list of files, to do that by hand takes a while. And so it's a lot more worth it in order to automate this really boring stuff. That's the whole idea behind learning programming in the first place, right? Is you want to take a bunch of really simple operations, make it really, really fast. So today our goal is to do this with bash script. And we're going to talk about why you might use a bash, a bash script as opposed to something you might be more familiar with, like say a Python script. So a shell scripting language is a way to automate some of the commands that Addison talked about in the last lecture. It's really, really well optimized for processing and handling a bunch of different files in different directories, for looking up different files. Basically, a lot of stuff that you would do by hand to just traverse the command line, you can automate to make a lot faster. The good news about bash is that all that important stuff is built into the language. It's not like in Python where you have to import special libraries to do so. The bad news about bash is it's really, really not fun to write or to read. So today we're going to try to make sense of it a little bit. But I think if you're wondering on a high level, when should I use this, right? I think that's the whole point of this class, is it's stuff that you should really use out there in the real world. One good rule of thumb is if it's a short sort of hacky fix, right? It's just like a short series of commands you want to run a lot of times. Maybe use a bash script, right? It can just very directly get done what you want to get done. If it's complicated, if there's a lot of logic, if there's a lot of data processing, maybe turn to something more like Python, right? Where it's a lot easier to write and it's just better at handling more complicated logic. So that's when you might use bash, is for like quick hacky fixes, and use Python or a different language if you want to do more complicated stuff. Does that make sense? Yes. Okay, awesome. Sweet. So today's going to go mostly in terms of demos. Let me actually share screen here. And okay, can folks see this? Yes. Okay, awesome. So the demos are just going to sort of walk you through the basics of shell scripting, and you should be aware that I'm following very closely this from the Missing Semester website. It's also on our website, but if you want to follow along, just go ahead to this page and you'll see more. Okay. So let's start just by seeing what the nature of a shell script looks like. Let's go to our first example. Oops, gotta move this. I don't need me there. There we go. Okay, so what does this look like? At the very top, we have this shebang line. We call this a shebang, which is such a fun name. But what it does is it tells our shell what program to run it with. So in this case, we want to run it with the bash program. So we give it a path to the program that executes the bash script. Oh, can we not see? Oh my God, it's so dark. I'm so sorry. Let's actually first see if we can. Let's see if we can see this. Can you see better now, or is it still hellish? Oh no. Okay. We're gonna change this. Okay, let's see. This is gonna be ugly, but it should be okay. I'm so sorry for all of your eyes. Ah. Okay. Okay. Let's see if this works better. Okay, we don't. Let's get rid of this. Better? A little bit? I'll make it bigger. Can we see? Okay, awesome. So sorry about that. And apologies for the ugliness now, but we'll deal with it. So this is our shebang line. This tells us what program we're trying to run it with. And this is our path to the program, right? So if I look in my bin directory, we'll see there's actually a bash program that's just an executable, right? Like any other program. Comments in shell scripts are left with this, this pound sign, right? So this is just a comment, just like you would have in like Python, let's say. The way that you set a variable is with an equal sign. Something that's really annoying about bash that you should know is that it doesn't deal with spaces in the way that you expect. This doesn't work, but this works. So all the fun stuff we've learned about like Python not caring and all that, unfortunately, bash cares a lot about these little minutia. Okay, so this is how you would set a variable in a bash script. And remember, our echo command prints something to the command line, right? So I've made this executable. So I can just run this. And notice one thing here. Notice that when we print this foo variable, two things. First of all, we evaluate it with this $sign. Okay, this is a way of like reaching in and grabbing the value from the variable foo as opposed to just treating it like a string. Also notice that these outputs are different. When we have two quotes, these double quotes, it will actually evaluate stuff within it. When we have a single quote, it doesn't evaluate as much stuff within it. Now, there are exceptions to this, but I will caution you to look those up because as with many things in bash, the devil is in the details. Just Google it if you're wondering what stuff gets evaluated in a single quote in bash, or ask these two people.
On Piazza.
On Piazza. Okay. So this is just a straightforward example of set a variable, print a variable, and then see that single quotes and double quotes are treated differently. This is like our hello world. Are there any questions so far? If so, tell Piazza. Okay. Yeah, I'll answer a question. Go for it if you want to. I think you can, all of these are available on that website that I linked. It's on the Missing Semester website, so you can copy and paste those in. Alternatively, yeah, just try messing around with it, doing what you want to do. Okay. So this is like a nice program, but not terribly interesting. So we're going to go into our second example. We're going to see how to do a function, right? That's our basic module of programming here. A function in Bash looks, remember, these are just our comments. So what does our function look like? Well, we declare it. Unlike a lot of functions that you'll see in other languages, typically we don't put parameters in here. Typically, you pass in parameters as arguments spaced one after the other after you call the function. What does that mean? That doesn't, I explained that badly. We're going to show you what. So we're demonstrating this function. First, I'm going to set a couple of variables. This outer dir variable is going to set to the string outer. The inner dir is going to set to the string inner. So it's just like before. And this is just getting comfortable with variables, right? Now what we can do though is we can call this MCD function. Let's talk about what it does in a minute, but we can call this function, and the way we pass in parameters is we just place them immediately afterwards. So this should look familiar. It's a little like when you're calling, echo hi. The way that you pass in hi to that function is you just put a space and then you pass in that argument afterwards. Okay. Oops. Okay. So what does our function do? What it does is it makes a directory with this weird $1 thing. So we'll talk about that in a minute, but it makes some directory and then it CDs into it. So this should make a directory and CD into it. This -p flag, you don't need to know about too much, but what it does is it will make intermediary directories along the way. Basically, if you try to create a nested directory right off the bat, this will allow you to do that. Let's talk about what this $1 variable means. This actually is a way to access the arguments that are passed to your function. Okay, so for example, when we call MCD and then this string, which is evaluating outer dir, the fact that this is immediately after our call to MCD makes it the first argument. If I wanted to pass in a second argument, I could just do it like this. This would be my argument 2 and my argument 3. This $1 is a special variable that lets us grab the first out of these 3 arguments. So it's just going to select this outer dir argument. Okay. Now we're going to also look at how this affects the state of our program. So I'll enter because there's some extra stuff going on here. So, okay, what should this do? This should create a directory called outer dir and CD into it. Or it should be called, sorry, outer, and it will CD into it. It should create a directory called inner and CD into it. Then we're going to do some script magic to print out the current working directory just to see where we're at. And we expect we should be in the innermost directory that we created, right? Okay, right? We've created 2 directories, we've CD'd into it each time, and we should be in the innermost one. Okay, and then we'll create this hello file. Okay, first thing we're gonna do is I'm not gonna worry about this for now. And we're gonna run this and just see what happens. Okay, so what does it do? Well, it prints out the directory that happens after CDing in, and we end up in this inner directory, which is good. We like that, right? Okay, and just for simplicity, I cut it off there. But you'll notice one thing, which is if I check what directory I'm in right now, I'm actually in the same directory I started at. I am not actually in the outer directory. So you should be aware that the outer program, which calls this inner function, right, or which calls this shell script, right, is not always affected by it, right? So just because within the shell script we CD'd into the inner directory doesn't mean that it takes us who called it into that inner directory. Think of it a lot like a local variable. Remember in like Python, when you call a function, you can define a bunch of local variables and they're going to affect the state within that function, but they're not going to affect what happens outside unless you specially ask it to, right? It's just like that. So similarly, if I try to ask, okay, what is this, let's see, what is this outer dir variable? It doesn't know. When Bash doesn't have a variable defined, it's not going to give you an error, actually. It's just going to give you nothing there. It's just going to be like an empty string. So what this is saying is this outer dir and inner dir variables are just local to the script. CDing into that inner directory is just local to the script. So be aware of this. there's ways to override this. There's a keyword called export, but just by default, everything lives within the script. Okay. Okay. Cool. And you'll notice one way to interact with stuff outside of the script is just to create files and deal with stuff that way. So notice we still have this outer folder. We still have this inner folder. And within this inner folder, there's this hello file that we created. So our script actually went into the inner folder at some point. It's just as soon as it quit, we're gone. All good. Okay. And I just have this here for when I'm debugging. Okay, so we're going to look at the third example here, because we've already talked a little bit about it, but not too much. Let's talk a bit more about these special variables, right? We saw this $1. Like, what was that doing there? And are there more, right? So in fact, there are many. This is just a few of them. But we might, for example, want to get the process ID of our script. And to do that, we put in $2. Why? I don't know. I don't know why bash syntax is the way that it is, but it just has historical relevance, I guess. I don't know. If we want to ask what the name of the script is, this is kind of interesting. We ask this $0. So I'll show you why this makes sense. So we're going to print out all this stuff. When we want to access the first argument, which is here, we use $1. The second argument, we use $2. And the third argument, we use $3. So it makes sense that $0 will actually give us the name of the script that we just ran. Right? It's all just like an array. So this tells us the process ID. It tells us the name. And I just wanted I wanted to put this here so you know that arguments can have spaces, right? Even though we use spaces to delimit them, if you want to pass in a string with spaces, for example, just quote it or use an escape character. Okay. A couple of other things you can do. So we passed in arguments. We can grab all of the arguments as this sort of array-like object. We can get the number. The other thing is we can reach into the history of how other commands ran. So for example, we're going to run a successful command, which is just echo, and that should work, right? Then we're going to use this special $? Right? And what that does is it asks us what the return code of the previous command is. In general, a return code of 0 is good. It's like there's 0 errors. A return code of anything that's not 0 is bad. Okay, that's a good thing to know just in general. But so we'll notice when we run a successful command, it's going to say our return code is 0. When we run a failing command, like say I try to remove a file that doesn't exist, that's going to crash, and then its return code is 1. Cool. Okay. A couple of other things you should know. There are some commands that work on the command line, but don't actually work in the script itself. So for example, if I do this double exclamation point, that will run the previous command again. But if I try running it in the script, it's just going to give me exclamation points. So notice that the shell command line environment is actually a little bit different than the scripting environment. If you end up with weird bugs like that, just look it up. So this is all a game of how well can you Google obscure Unix commands. Okay. Okay, cool. All right, that's it for now. So this should tell you we have some way to access the history. One other thing you should know about shell scripts is that they have generally 2 output streams. They have something called standard out, and they have something called standard error. So we've already talked about standard out when we talked about piping and when we talked about like redirecting outputs into files, right? That's basically just like, what text does your program produce? What if something goes wrong? In that case, there's actually a different output stream that's called standard error. And the reason these are important is we can redirect these, right? So say I ran this, and I can write this to a log file.txt, right? And that will just, yeah, and that's, notice that the standard out gets redirected to log file.txt, but this error message remains. It's because they're 2 different streams. So now if I look at log file.txt, I see a bunch of stuff there, but that error command is gone. Right? That's because it went to standard error. Okay. what happens? How do we redirect standard error? Well, we can use these sort of delimiters where 1 redirects standard output and 2 redirects standard error. This is super useful. Say you're running like a really big script on a machine and you want to leave for the night, right? But you don't want to like have to watch the logs all night. What you can do is you can leave it running in the background, redirect the standard output to a log file, redirect the standard error to a different log file. And then when you wake up in the morning, you go and you check both of them and you pray that it hasn't crashed. But if it did crash, you check standard error and you know how to fix it. Okay, so this is like super useful. Yeah. Oh yeah, good question. Don't worry too much about it, but it's a way to for me to use like string formatting, like this /n. Otherwise, it'll just print it by itself. Yeah. Okay, we good so far? This is standard out, standard error, redirecting. Okay. Oh, and now if I look at error.txt, I just see the error message. Okay. So these are these special variables. There's more, but again, that is a Googleable skill. Okay. This is so sad. Okay, now we're going to look a little bit at conditionals. So we've been talking a little bit about all the weird oddities of Bash, but let's start to draw some parallels with, say, Python. Okay, so if y'all have encountered short circuiting before, this will look familiar. If you haven't, we're just going to go through it briefly. The details aren't like the most important in the entire world, but you should be aware that this exists. So we have these Boolean operators. These 2 parallel bars represent OR, and these 2 ampersands represent AMP. So how do these behave? Well, this OR operator, as soon as it finds a true value, it's going to stop. If you think about it in logical terms, if you have multiple values and you're ORing them together, as soon as you find a true value, you can just stop because the whole expression is true. That's how it works in propositional logic, but in programming, this is called short circuiting. So as soon as we find a true statement, we drop the OR. Okay, and true in Bash just mostly just means non-zero. Okay, so what's going to happen when we run this? This should we're going to see a false value, and then we're going to have to keep going to look for a true value. Similarly, if we see a true value up front, we're not going to print out this message, right? Okay. Now, what happens with the ampersand? Well, first, we're going to see a true value, so we're allowed to keep going. And then we're going to echo things went well, right? But if we see a false value anywhere in an AND statement, then we can just quit because the whole thing's false, right? And so then we're just going to return this false and not echo anything. But what if we don't run conditional logic, right? Like it's ugly to write true and all the time. Then we can use these semicolons, and these just separate different commands on the same line. So it doesn't matter, true, false, whatever, it's always going to run. Okay. Any questions on that? How are we doing on questions, by the way, Addison, Aaron?
We don't have any.
Oh, okay, awesome. Ask more. This might be.
You can also drag this to the very top.
Oh, that'd be fantastic.
And then move your mouse down.
Yeah. What's up? That's really not. Oh no. Sorry. Oh, I appreciate that. Thank you so much. That one. Okay, I appreciate that. Thank you. Okay, we're gonna go back to it. Oh, okay, there we go. Good. Never mind. I'm very bad at technology, actually. This is just something you should be aware of as I teach you about technology, is that it doesn't like me. Okay, so that's how that runs. Let's look at some other interesting stuff here. Let's see. We're gonna go straight to exercise 6 because we'll incorporate. Okay. So okay, let's put some of this stuff together in a program. And you'll also notice a couple of new elements here that might look familiar from other scripting languages. So we start with the shebang at the top. That's important. That tells us what program to run it with. Can you get away with not running it? Yes, you'll have a default shell, but just for portability, put this down. Cool. So we're going to start a program. Let's just see what happens, right? We have a for loop. Okay, we have for loops in Bash, although their syntax is really ugly. It's Googleable, but remember this special variable grabs all of the arguments that we pass to it. So it's going to grab all the arguments sort of as like an array. We can iterate over everything we pass to this shell script. We're going to go through each argument. We're going to name it file. And then what we're going to do is, I'll just tell you this, this searches for the pattern foobar within the file. Okay. And I'm redirecting the output to just null. So that means it's not going to output anything. Notice that this is this standard out or is this standard error? This first one. Standard out. Awesome. Okay. And then this 2. Standard error. Okay, awesome. You might be wondering, like, should there be a 1 there? And the answer is, yeah, if you want to. Either's okay. But this is a classic example of redirecting. I don't want a bunch of noise from grep. I just want to send it to null. Okay? Okay. So what is this doing if it's not doing any output? Well, we can access its history. We can go and I don't expect you to have this memorized, but this is the command we saw earlier that gets the return code of the previous command. The previous command is this grep command, right? If it finds foobar in the file, then it's not going to error. So what's its exit code? Exit code? Yeah, 0. Okay, awesome, right? If things go right, there's 0 errors. If it doesn't find foobar in the file, its exit code is going to be something else. Let's work with that. Let's see this if statement, again with ugly syntax. If this return code is not equal to 0, what does that mean? Error or no error? Error, right? Okay, and if it's an error, did we find foobar? No, okay. So basically, we're only going to go in this if statement if we didn't find foobar. Then what are we going to do? Well, we're going to echo this, which totally spoils my question. And we're going to echo this string foobar into this file called foobar log. So basically for every file that doesn't have a foobar in it, we're going to just keep adding the word foobar. It seems useless, but you'd be surprised at like how many rote tasks look somewhat similar to this actually. Okay. Yeah.
What do the 2 double arrows mean?
Oh, good question. So this is a review from last lecture, but again, there's big info dump here. What the 2 arrows do is they take the output of this command and they concatenate it onto the end of the file. A single arrow, so if I were to do this, this will overwrite foobar log with that output completely. It's going to get rid of everything in it and just give it the output. But when I put this in, it's going to concatenate it to the end. That makes sense? Awesome. Great question. Any other questions? Does this feel like really dry and boring? Because to me, it does a little bit. It's okay if it does to you as well. This is the nature of Bash scripting. I wish I could say it gets more fun, but it is useful. Okay, yeah.
What does grep mean?
What does grep mean? Do you know what the etymology is of grep?
Is that something like grep in Python or Java?
Yes. So what grep does basically is it just looks for a pattern within a file. So you can search for some string within a file, and we're going to talk about that later. And the answer is yes. Generally, using regex like type stuff in Python, you can do the same functionality. Do you know what? I don't know what the word grep comes from. Yeah.
Grep is a reference to the things you type to do a similar thing in the old ed text editor.
Oh, okay, good. History lesson.
Question on Piazza. We'll give you a more in-depth response.
Awesome. Yeah. But don't worry about it for now, because we will teach you later. Okay. So what happens? Well, let's see what happens first if I just try to run it. Okay, it tells me it starts the program, it tells me it's running, but nothing really happens, right? Why? Why does nothing happen here? I'll get back to it. Yeah.
You didn't pass any file.
I didn't give it any files. Okay, good, right? It's gonna iterate over all the strings that I give it, but I didn't give it any strings, so it's just gonna quit. That's kind of lame. Okay. By the way, let's look inside these files and see what they say. If we look at file 1, there's no foobar. If we look at file 2, there is a foobar there. If we look at file 3, there is also no foobar there. Okay, cool. Okay, so what are we gonna do? What we're gonna do then is we're going to run, and we're gonna give it file 1, file 2, and file 3 as arguments. Now it's gonna look through each one of those, and it didn't find a foobar in 1 and 3, so it's gonna keep concatenating this foobar string onto the end of this new file called foobar log. And we're going to see 2 of them, right? Is that not the most exciting thing you've seen today? Okay. I'm sorry, but yeah, that's just kind of how it works. Any questions on that?
Why do you add foobar sometimes?
Oh yeah, good question. If you're asking like existentially, like why am I doing this? Just instructionally. But in terms of how this program works, it's because we looped over 2 different files that didn't have the word foobar in it. So that's why it happens twice. Why am I doing it? I don't know, like for fun. Mostly because that's what it says on the website, and I wanted to be consistent.
I thought you added the foobar for the first file.
Actually, maybe ask on Piazza. I'm not sure I quite follow, but yeah, ask on Piazza and they can help you out better. Sorry about that. Yeah. Okay. We're going to get to some more. Now we're going to get to some stuff that's like less about scripting and more about like finding files, moving files around. This is the stuff that day to day, I think will make your life a lot faster, frankly. Okay. So I don't think I have any scripts I need to run in here. So let's just see what it looks like. Whoops. Let's see what it looks like in this folder. We have a Py script. We have an sh script, a couple of them. We have an empty folder. And we have some image.png, right? So we're going to try, let me see, let me pull this up. Okay, we're going to do a few things. First, we're going to notice how to use this star command. So this star matches any number of characters. So if I, this basically will just match anything. If I do ls star.sh, then it will match any number of characters, but then it has to end with sh.sh. So this will just give me all the shell script files, right? If I want to move all the sh files into the folder, I'm just going to grab all of them with this glob. That's the name of this star. And I'm going to move them to the folder. And now the folder has all my sh files, okay? This is really useful. Say you download a bunch of like stuff into your downloads folder and like everything is a PDF, right? You can do like ls downloads /.pdf to look at all of them and then move them all into whatever folder you like, right? Makes things just super quick for you. Okay. Well, let's move that stuff back. And now it starts with folder and it ends with anything. We're going to move it back to our current directory. So this is something you'll get more used to, but this is a useful thing, learning how to glob. Let's also see how we can use curly braces in order to establish different options. So say I want to move, we have, let's see, we have this image.png, right? Let's say I want to move that to image.jpg. Whatever. That's not going to convert it, but let's just say I'm renaming it. Okay. One other way we can do this to save ourselves a little bit of time is we can do move image dot, and then now we're going to give it 2 options. We're going to give it PNG, comma, JPG. Importantly, there's no space here. If I put a space here, everything blows up, which is annoying. But what is this going to do? Well, this is kind of weird how this works. What it does is it actually takes this expression and it copies it into 2 expressions. So the first expression is going to be image.png, and it's going to put that first. And then it's going to create image.jpg, and it's going to put it as an argument immediately afterwards. So it's going to do the same thing as before. It's just going to construct this command up here. So this first bit becomes the first command, and or this first argument, and the second bit becomes the second argument. And everything works. Right? Okay. Here's another example of how you can do that. Let's say we want to move everything, all our Python files and all our sh files into the folder. Okay. let's just think about this for a second. So I'm not going to go through this immediately, but think about how you can combine globs, okay, we don't care what the files are named, with this expansion tool in order to move both options, but nothing else, into the folder. And you don't have to tell me your answer, but just think about it, write it down if you want. I'll just give like 30 seconds. And if you've already solved it, that's awesome. I don't know, look up some new Unix commands or something. I don't know. Yeah, discuss with your neighbors. It's a collaboration. Introduce yourself if you don't know them. Yeah. Sorry?
What was the question again?
Which question? I think, oh.
What were you asking them?
The question was, why do we add this twice, I guess?
Oh, okay.
Yeah. Okay, 15 seconds and we're gonna wrap it up. Okay, we're just gonna wrap it up now. So how are we gonna do this? Well, we don't care what the file is named, so we're gonna start out with this star glob, right? That's gonna give us, whoops, that's gonna give us any name to begin with, but we want it to end either in a .sh or in a .py. So there's two ways you can do this, but I'll put the dot inside, sure. So one way to do, to verify your commands before you run them is just run ls first sometimes if you just want to see what files you're grabbing. For example, if you're trying to delete a bunch of files in your directory, but you're not quite sure if your pattern is right, like please, please, please use ls first so you make sure you don't like delete a bunch of stuff off of your desktop. Once upon a time, I ran a shell script in my Google Drive that deleted my Google Drive, like all of my Google Drive. Eventually I got it back, but like, just so you know, it's a hassle. There was one space in the wrong place. I'll show you what the script looks like and be very careful not to run it. So this is how you can tell. We're grabbing all of our sh and py files, and then now we can just move it to folder. And that's what we want. Okay. In case you're wondering, and this is gonna be dangerous, but I wanted to run something like, whatever, right? Like some directory starting from root, and I put an extra space there. It was rm-r, right? That will recursively delete everything from my root. There are some fail safes, you sometimes have to run -rf, like Google Drive didn't have those in place, and boom, there goes my Google Drive. So be careful when you're shell scripting not to run stuff you don't intend to. Is that good? Okay. Okay, so we've done some stuff here. Let's play around with this a little bit. Let's create some new directories. We're going to use our favorite words, foo and bar. You're going to see those all over the place on like Unix Stack Exchange. I don't know why, but just get used to it, I guess. And what are we going to do? Well, let's say we want to create a bunch of files at once. So we're going to use our expansion trick. So our input folder is either going to be foo or bar. And I'm going to use a little fancy syntax here, which is going to give us a range of letters from A to H. I could also do like 1 to 5, anything like that. But this is just going to give all the options of A, B, C, D, E, F, G, H. Okay. So what is this going to give me? It's going to give me all of the combinations between foo, bar, and then A all the way through H. Okay. What do these look like now? Well, just like we expect, right? Now, let's see what happens. Let's add an extra thing to each directory. Let's add X to foo and Y to bar. So these are a little different now. Right? Let's do one extra command. I think this is kind of an interesting one. So we're going to run the diff command. And what diff does is it takes in 2 arguments, and those arguments are files. And it's going to give you sort of a summary about how those 2 files differ in their content, right? But what are we going to pass into it? Well, diff doesn't take in input from like standard input, right? It takes in 2 files. So we're going to use a little bit of like a little trickery here. We're going to use this structure. So this is a weird structure, but you should be aware it exists. What it does is while this command runs, it creates a temporary file to hold the outputs of some command that we run. And that file is going to be gone afterwards, but we can use it as an argument to other commands. Let's write out this command and I'll just show you why it's motivated, right? So let's say we want to list out all the contents of foo and list out all the contents of bar. We want to see how do these directories differ in terms of their contents, right? Well, both of these are now going to be put into temporary files, and then diff is going to find the difference between the contents of those temporary files. At the end, after it's all done, it's going to delete them. Sound good? Okay. Little inscrutable, but you'll notice that the one on the left, foo, has X. The one on the right, bar, has Y. And if I look for any extra files, there aren't any. So that's why they're temporary files. So this is a little hack. If you have a command that takes in file inputs, you should know this sort of little less than sign looking syntax. And this is an alternative, for example, to if I tried to do this, which evaluates it but doesn't put it into a temporary file. There's gonna be some weird stuff. Okay. Cool. We're not dead of boredom yet. I'm gonna go through, let's see. What time is it? It's 7:20. I have 2 more examples, but I think we're gonna go just take like a 3-minute break because we've been staring at the shell script for a long time. So we're gonna take a 3-minute break. We're gonna regroup at 7:24, okay? And then we're almost done. Okay. Talk with your neighbors. No, mingle. If you have questions, you can come up in the meantime.
Oh, yeah. Well, we have the last like half an hour. To make it so we can. Just say that the last half hour is just for like it's like about time, but it's over.
Yeah.
So they can get started and ask questions because I'm sorry. Also, if you want.
All right, it's 7:24. We're gonna take the last 6 minutes of demonstrations. Don't worry, they'll be over soon, and then y'all are gonna dig into the homework. Okay, so let's close out this demo real quick. Okay, this should be like a welcome relief, which is, let's say we go to our example 8 here. notice that we actually don't need to use bash as our scripting language. For example, if we have Python installed, all we got to do is change the shebang to point to a folder that contains our Python installation. Now, when we try to run this script, notice the script doesn't have like a .py or anything like that. It looks like everything like we had before. But what's going to happen is our shell is going to read the shebang and it's going to interpret the rest of the file with a Python interpreter. So hello again, beautiful syntax. Fantastic, right? Now, if we go back to, if we run like, oh, whoops, my bad. That would be cheating. Let's say we just run the script with hi, how are you? It will reverse the arguments and say you are how high. Okay, cool. Awesome. Okay, very important. So yeah, basically, if you have stuff that gets really complicated, don't worry about it too much. Just, you can always use Python if you want to instead, and just get more comfortable with bash over time. Sound good? Why is this useful, by the way? If you're wondering, like, why would we even put Python in this weird script format instead of just running Python 3 like normal? Sometimes other programs take in executables as like an input, right? So if you have, for example, a program that runs a cron job, like, you know, every day at some specified time, right? It's going to run something at noon every day. A lot of times, it's not always possible to like configure that to run custom commands, or it might be a little annoying to do so with a certain library. So sometimes they just want you to pass in a file that you can just execute in the shell. And this is a way of doing that with Python. Isn't that great? Okay, sweet. Last example. It's about time. Last example, I think are the two maybe most important ones here. So sorry, everyone who left. Okay. We're going to talk about the find command and the grep command. You've seen grep before, but we haven't really dug into it yet, right? So let's see. And then we'll talk a little bit at high level about how to learn more about new commands. But what do we have here? Let's look at our files. So we have hello.png, we have some temporary file. We have this source directory, we have a test directory out here, we have a hello directory. This is like hopelessly disorganized, like many of my code bases. And you might be wondering, where is one of those files that I made 6 months ago, right? One way you can do that is you can use this find command. And find has weird syntax. If we want to look for the syntax of the given command, one way to find that in long form is to run the man command. So every command you have, you can run man and then that command, and it'll give you this manual. This is probably more information than you need, but this is just really good if you see something weird on Stack Exchange and you're like, what does that flag mean? Just look up the manual or run the man command and it'll help you out, okay? What you'll notice about the find command is there's a ton of different flags. There's a ton of different configurations you can run it with. So the syntax is a little scary, but let's start with a couple of, it's because it's so powerful. It can do a lot of different things. Let's start with a couple variants of what you can do. So we want to find stuff from the given folder, and we want the name to be source, and we want it to be a directory. Don't memorize this, you don't need to, but just so you're aware of what this can do. Find by default is going to recursively traverse these directories and find files, in this case, that have the name source that are directories. So we have source in our current directory and one that's nested, right? Okay. Just again, get used to some of these configurations that will make life faster. Another example is, let's say we want to find some files that have a specified path, right? So what we're going to do is we're going to, again, find from our directory, but now we're going to specify that the path has to fit a certain pattern. And here are our old friend, the globs. So our path is that it has to have the word, it has to be in a directory called test, and it has to be a Python file. And to enforce that it's a file, we'll say type F. Remember, type D was our directories. And that's what it's going to do. So same sort of thing, but it's only going to grab the ones that have test along the path. Sound good? Okay. Again, don't memorize this. This is just like what it can do. Say we want to find all the files that I've created in the last day. That's all of them because I was unprepared for this lecture. Okay, let's see. There's other stuff you can do, like you can find stuff that's by a given size, for example. But again, there's so many options that really you should just figure out what you're trying to do and Google it, and someone's probably done it already. Cool. Okay, I'm getting nods. That's good. One other thing you can do with find is you can execute commands on the stuff that you find. So be careful with this, but for example, say I want to find all the temporary files and I want to delete them. This syntax is replaced by the name of whatever you find. So if I find a .temp file, these braces are replaced by the name of that file. This RM is going to delete it. And this closes the program. Now, if I look for my temp files, they're nowhere to be found. Okay, for example, let's do another one. We have this PNG, right? Let's say we want to do find. We want to find all of our .png files, right? And what we're going to do then is we're going to just move them to a JPEG file. Same sort of thing. So we take whatever was picked up beforehand and just turn it, in this case, .png.jpg. Okay, that's a bug. But you see why I did that was because this grabs the whole PNG and then it just tacks JPEG onto the end of it. So if you want to get fancier with it, I would say you can either use like some cut command in here, or more likely you wouldn't use it in just a single find. You would just write a small shell script to do that for you. Okay, but you see find is like really powerful. It's kind of over-engineered. Okay, last bit. So that's how you find stuff by name, right? But say I want to find something by its contents, right? I wrote this happened a lot in my research is I like wrote a file, let's say, that calculated some integral. And I was like, I don't remember where the integral code was. So what I'll do then is I will use this grep command to search all my files for the word integral, right? And if it's there, I can probably track it down. So let's see, this grep command, what it does is unlike find, it takes in a pattern first. Let's, for example, one of these files in here has import requests. But you're going to notice something, which is it's not going to go recursively into directories. Find is automatically recursive. Grep, you have to pass in this -r command. And this is really common. And now it will recursively search the directories. And deep inside in source test howdy.py, there's this import request line. Sound good? Okay. I don't expect you to know this syntax. That's really important. So this whole lecture, I've gone through a lot of syntax that you're not familiar with, and I'm expecting it not to stick. The most important thing that you should take away from this is all of these tasks that can be completed by Bash. Okay? If you want to find a file, you know that it is possible, and you can Google it, and 5 minutes later, you can find it, right? You do that for a few months, you do that for a year, and then it's second nature to you. It's not even second nature to me yet, right? Like, I think it's probably second nature to these guys, not to me. But I guess maybe that gives me some empathy for you. Maybe that makes you wonder why I'm up here. But I think the most important thing from this lecture that you should take away is there are a bunch of interesting things that you've seen today that you can do with Bash scripting. And the syntax isn't too scary. And it's going to make your life a lot faster if you just get used to it over time. Sound good? That's it for the lecture. Here's what we're going to do. There is a homework out. And the last 30 minutes are going to be reserved for lab time. So y'all can just hang out with each other. You can work on the homework together. It's going to take a lot less time. Build some community. We'll also be around for like de facto office hours. If you want to get going and eat dinner, be my guest, go ahead. That'd be great. But also, I think this is probably going to save you time in the long run. So it was a wonderful lecture with you all, and I will see you next week and/or in Monday.